All right, so here we are in 3.1, the handout. And we've been working backwards. We did 18, 17, 16, 15. Back to number 14 now. It says sine to the fourth minus cosine to the fourth. Okay. So, any ideas? Elise, you said you solved a bunch of these. Do you have an idea? Do you remember what you did on this one? Anybody remember?
I did all of them, so I was pretty sad.
Yeah, no problem. Anybody remember? Do you remember factoring from algebra? Do you remember how you can factor something like x to the fourth minus y to the fourth? Do you remember that kind of thing from algebra a little bit? Like where you do like the two parentheses called factoring? And you figure out what would multiply to be, like what times what would be x squared, x squared, right, would be x to the fourth. You know, thinking about what would multiply. That's called factoring, when you think multiply backwards. And you say, okay, what would multiply? X squared times x squared would make x to the fourth. Remember when you multiply x's, the powers add? Remember that kind of rule? No, you guys are giving me a look like you never had algebra. No, you guys remember that, right?
Like difference
sort of.
squares?
Differences, that's exactly what it's called, difference squares. And I understand, I'm not expecting you to memorize it perfect. But you just sort of remember that with the parentheses, and remember like in the back numbers, what would multiply to be y to the fourth? Yeah, it's difference of squares. I never use the names. But yeah, Chrissy, you're totally right. It's the difference of squares is what it's called. Now y squared would make y to the fourth. Coming back a little bit, right? This times this would make that one. So it's also called FOIL. You know, the front times the front makes the front, right? X squared makes x squared, and the last times the last makes the last. Now, how do you make negative y to the fourth? What signs do I need? I haven't put the signs in the parentheses yet, pluses and minuses. What signs, how did two things multiply to be negative y to the fourth? Yeah, one positive, one negative. Either order doesn't matter as long as one's a plus, one's a minus, huh? Yeah, that's the right thing, right? So that's what I'm going to do with this sign stuff here. I'm going to go, oh, that's just like an x and a y, except it's a sine and a cosine. So I'm going to go sine squared, make sine to the fourth, right? And then cosine squared, make cosine to the fourth. And what signs do I need to make negative cosine to the fourth? Again, 1 plus, 1 minus. Either order doesn't matter. We good so far? Now, what is sine squared plus cosine squared?
1.
Yeah, that's a big one. Remember that Pythagorean identity that we have learned? Sine squared plus cosine squared is 1. Remember that? Right, so I'll write that over in the side. So you want to know those. Those are we're going to just keep using again and again. Sine squared plus cosine squared is 1. You want to just really start to know that one. And then 1 plus tangent squared. You can put them on your card, of course, for the... Wait, that's not right. Cotangent squared. I'm making stuff up there. 1 plus tan squared is secant squared. And 1 plus cotan squared is cosecant. So those three, they're called the Pythagorean identities because they all come from a squared. They're all like a squared plus b squared is c squared. That's what they come from. Anyway, know those three. I mean, no, you're going to have on your 3x5 card, but the more you just kind of have them in your mind, you'll recognize them when you're trying to do these little identity problems. It'd be easier if you kind of have them in your mind. Then you'll see them and identify them. Anyway, is that enough? Is that answer there? No. Okay. So 1. Let me bring this one down. Okay. So good so far. This becomes 1. This just comes straight down. So this is just sine squared minus, because 1 times anything is just itself, right? That 1 vanishes, right? Because 1 times sine squared minus cosine squared is just sine squared minus cosine squared. Now, I wish that answer was there, but it's not there. Now what are we going to do? You look at the end. This is where these things are tricky. This is where they're tricky. Because you think, well, what do we do now? Well, here's another trick that they often do that you're going to want to be aware of. That's why these are hard. That's why I'm promising to give you these exact questions, and I'm not going to mix them up on you. It's going to be these 5 of these. Out of these 18, exactly 5 will be on exam number 3 a week from today, next Tuesday. So learn these and you're good. So anyway, what they do, a common trick, is they'll take that first Pythagorean identity. This one's super popular. They use it all the time. Let me just write s squared plus c squared, just to keep it simple. I just use s and c when I can, save time and space. Sine squared plus cosine squared is 1. Okay, so what? Well, do you realize if you get either one of those alone, what will happen? What if I grab the cosine and jump it to the other side? What will happen? Sine squared will be 1 minus cosine squared, huh? Remember, when something jumps to the other side, the sign in front of it changes? I really just subtracted cosine squared from both sides. We good there? Is that making sense? Or another option. So what I'm saying is, this is something you can use a lot of times. Or another thing you can use is you could jump the sine squared. Because you think, well, how do you know which one? It's either one. Cosine squared is 1 minus sine squared. So what those are, you can write that down here. Sine squared is 1 minus cosine squared. Or cosine squared is 1 minus. You might want to put all 5 of those just right on your 3x5 card for the exam we take next Tuesday, a week from today. So those are just different versions of that original one, huh? But it's helpful just to have them right in front of your eyes. Remember what they are? They're identities, meaning they're of identical value. So that means wherever you see sine squared, you're free to replace it with 1 minus cosine squared because they're equal. They're identical value. And wherever you see cosine squared, you're free to replace it with 1 minus sine squared. Now, take a look. Do you see it? Right here I've got sine squared, don't I? Let's get back to our main problem. Sine squared. Sine squared is the same as 1 minus cosine squared. So I can replace this with 1 minus cosine squared. And then just bring down the other cosine squared. Everybody see that? See what I did there? So that first sine squared becomes 1 minus cosine squared, right? Because sine squared equals 1 minus cosine squared. So this sine squared I can replace with 1 minus cosine squared. Is that good? Yeah. And then bring down the other cosine squared. Now I've got 1 minus cosine squared minus another cosine squared. What's that? 2 cosine squared. 1 minus 2 cosine squared. Does that make sense? And that's on our chart. Isn't that A? That's answer A. We're done. Because it's like terms. It's like an x and an x make 2x. It's 1 cosine squared and 1 cosine squared. Because there's invisible ones, huh? There's always invisible ones in front of those if there's no other number. So minus 1 and minus 1 is minus 2. Minus 1 cosine squared minus 1 cosine squared is minus 2 cosine squared. Remember when you're adding and subtracting letters, you just do the numbers in the front. But when you multiply letters, you add the powers. Remember those rules? So I'm glad to remind you of all those. Please don't be nervous to ask algebra rules. That's why we're here. I'm glad to help with all that. Please speak up. Other people, probably half the class or more, has your same question. So please speak up. You okay with all those little algebra rules? So like when they multiply, that's when the powers add. When you multiply letters like x squared times x squared, that's when you add the powers x fourth. But if you're adding, that's when you just do the understood ones in the front. Remember that difference with letters, the rules for letters from algebra? When you're adding letter things, it's just the numbers in the front. You don't mess with powers. But when you're timesing letters, that's when the powers add, huh? Remember those kind of rules? Well, that's what I just did down here. Minus 1c squared and minus 1c squared, they'd made minus 2. That's just adding, subtracting, just did the number in the front. Whereas up here, these guys multiply to be s to the fourth because multiplying adds powers, right? Remember all those rules? Questions on that one? We good? All right, I'll keep going forward. Let's look, or going backwards actually, huh? Let's get to number 13. Okay, so it's I'm just going to start abbreviating. Cosine, and this is fine with me too, for your own work on your paper, on your homework, fine with me. I'm just going to go c squared minus s squared over 1 minus t squared. Save time and space. That's cosine sine, and that's tangent on the bottom, huh? Okay. There's like a million things we could do here, probably. All right. Let me write them in over here again. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. 1 plus cotan squared is cosecant squared. And then the other two Pythagorean identities. Sine squared is 1 minus cosine, and cosine squared is 1 minus sine. So how about I just write down those 5? It seems like we use those all the time in every problem. There's the 5. Are we good with those? Everybody good again with those last two? Sine squared alone or cosine squared alone is 1 minus the other one, isn't it? Okay, so here we go. What should we do? Well, I don't know. What's that? Maybe, huh? Honestly, I'm not sure. I'm just kind of looking at it, figuring it out as we go here. I don't know. There's just a million things you could do. What is... I'd like to fool around with that tangent. I'm looking at the tangent on the bottom, thinking, can't we do something with that tangent on the bottom?
Okay, you just put tangent in terms of cosine and sine.
Yeah.
And then work with cosine and sine that way.
You could. We'd have a fraction on the bottom of the fraction is my only issue. I'm thinking that might be a little ugly. I don't know. Maybe not. I don't know. And what about the top? This one looks really kind of weird. Oh, that's right. I remember this is a super hard one. That's right. 13. Did I tell you that? I said 13 and 18 were really hard. Number 1, number 13 and 18. So I better look at my cheat sheet notes here. I wrote a note for myself. Said trick. Yeah, you're right, Elise. We're gonna go your way. Yeah. Let's do your way. Yeah. So that's what I'm going to do. Yeah, this is a super hard one. So this 13, 18, and number 1 are like the 3 hardest. At least they were for me. So this one is pretty, because I don't see it right. I'm looking at it going, I don't see it. Yeah, I'm going to do what Elise is saying. What tangent is sine over cosine, right? Everybody good to there? So I rewrote the tangent squared as sine squared over cosine squared. That became that, huh? Good there? Because tangent is sine over cosine. Remember that? We use that one a lot. Okay. Now it's kind of messy. We have fractions over fractions. My little note to myself here says that's exactly how I ended up solving it. So now, what do you do when you have fractions over fractions? Well, in this situation, you can't, normally we just grab the one on the bottom and flip it up, huh? But you can't do that when it has a minus. Remember, pluses and minuses wreck everything. Remember, I'm always saying that in algebra. If you're going higher, pre-calc, calc, you want to really that'll help you a lot of situations. Pluses and minuses wreck everything. They glue things together. So I cannot just grab this fraction independently and rip it off of that. It's glued. These guys are glued. I always say it's Costco to my algebra students. It's like Costco where you grab things and they're all packaged together. You got to buy in bulk. So the pluses and minuses glue things together. So no, you can't just grab that fraction here and flip it up. It's glued to the 1. You can't break that bond. If that was times, if that was 1 times, then you could totally just flip it up. No big deal. Who cares? But pluses and minuses, they glue things together in algebra. It'll really help you if you kind of have that in the back of your mind in a million situations. Pluses and minuses wreck algebra. They're what made algebra hard. All the hard rules are when pluses and minuses get involved, things are glued together. So that minus is saying, nope, we're a package deal. Don't just rip off that part and flip it up. Well, then what do we do? Well, here's what you do. You multiply the top and the bottom by c squared. So I'm going to put, is that what I'm going to do? C squared, top and bottom. Wait a minute, it's starting to seem weird to me. Yeah, I'm going to multiply the top by c squared and the bottom by c squared. It's making sense. In fact, let me just do each one independently. They all get their own c squared. So that's okay to do. And why am I doing that? Because that's the denominator right here. I don't want an extra denominator. See how I got fractions in the bottom of fractions? and I don't want that. That's messy, ugly. So how do you deal with that? Well, you multiply by that denominator, c squared. But you got to treat everybody the same, don't you? Whenever you mess with something, got to be equal treatment so you're not changing it. Same thing, top out, everybody has to get a c squared. But do you see why I motivated this to help you remember it? How are you going to remember this on the exam? You don't have enough room on that 3x5 card to write all 18 of these down. And right? So you got to really kind of feel it. It's because I want this to happen. You see, that's why I'm doing it. Do you see what will occur to you, I hope, and go, oh, I can do the c squared. Because I want to get rid of that. I don't want that extra fraction. Right? That good? So anyway, what do we get then? We get, let me bring it over here. We get c squared times c squared, c to the fourth, minus c squared s squared over c squared minus s squared. Everybody see that? How are we doing? Did I lose you? So I multiplied all four terms by c squared. It's c squared over 1, huh? That's why these canceled. And just left s squared. C squared times 1 made c squared. C squared made c to the fourth, s squared, c squared right there. Good?
Do they cancel out, right?
What cancels?
The top, like c squared on top and c squared on the bottom.
Yeah. Can we just go like that?
Yeah.
Mm-hmm.
What was I just telling you about Costco?
Oh, you cancel.
If that was times, totally. Yeah, really good question. I'm glad you're asking that, Samuel. I'm sure everybody has the same question. Really good. If that was times, totally. We would just cancel those away. And the s squared, no problem. Just cancel them all away. But because of the plus or minus, yeah. So let me keep bringing that because that'll really help you moving up line per calc. Calculus students, struggle with this too. It's a really important rule to get down. Pluses and minuses glue things. You know what I mean by Costco? Maybe I better slow down and say it a little better, right? We have 5 kids. My wife shops at Costco. You buy in bulk at Costco, right? You grab one plastic or one spaghetti sauce, and you pull it, and it's plastic to 2 or 3 others, right? You buy in bulk. Sam's Club, same thing, right? Those warehouse stores where you buy in bulk. Well, that's what pluses and minuses are like. You cannot take your scissors to Costco and just cut the plastic and say, thanks, I just want one. They won't let you do that. That's the whole deal. You're buying in bulk. Well, that's what pluses and minuses are like in algebra and all the rules of algebra. It makes them a package deal. So when you see, so Samuel's question is a good one. When you see this c squared with the minus here and the minus there, you should think this all is a package deal. What does that mean? You go like that or you don't touch it. You buy the whole thing or nothing. All or nothing. You with me? All or nothing on that. Is that good? So that's what I tell my daughters. I got 2 older daughters now. I mean, I don't tell them anymore. But boy is interested in you. He does all. It's marriage or it's nothing. There's none of this sleeping around before marriage. That's not a healthy, happy plan. Anyway, same thing. It's all or it's nothing. So is that good on that? That's plus and minuses glue things together. All or nothing. So it's a really good question. We can't do that. So we can't take it all, so we take nothing. So what do we do then? Let me put it back here. See, what was it? S squared, c squared. Doesn't matter. You can switch the order. It doesn't matter what order you have the s squared, c squared in. Fine either way. Yeah, so we can't do that. If it was times, we totally could. If it was times, times is fine. It's pluses and minuses that do the gluing that wreck algebra, make it hard. Okay, anyway, but we do need to do some simplifying, like Samuel's wanting to do. It's a good idea. We need to do something. What are we going to do? Thank you. So up here on the top, look at these guys. Remember factoring? So again, I'm reminding you of factoring from algebra. I know that's a rusty point. I remember my own 2 daughters when they were taking trig and pre-calculus a couple years ago. I was helping them. They were taking another teacher here, and I'd tutor them at night at the kitchen table. And every time I'd say, girls, you got to factor here, my Emma and Lizzie would go, Dad, I hate factoring. I hate factoring. And I'm like, well, girls, you got to learn to factor if you want to keep going on in math. So factoring, you remember factoring? Remember how that works? You look at this c to the fourth and this s squared c squared, and you say, what do they both have in common? What do they both have? What do these things both have in common? C squared. They both have c squared. Huh. This has even more than that, and this has the c squared then. Hand up? Yeah. So c squared, take it out. Remember like GCF factoring from your algebra? Like take out what's in common, they call it GCF. Take out what's in common, meaning, see, this has c to the fourth, so it has at least c squared, and that term has it. So then you put inside whatever works. Do you know what I mean? Like you say c squared times what here will go back to c to the fourth. C squared, huh? Yeah, because powers add, like we're talking about when you multiply letters, the powers add. C squared goes back to c to the fourth. Good so far? Minus, and then c squared times what? Goes back to s squared c squared. S squared. Is that good? Everybody see what happened there? Do you see how if I multiply this c squared times c squared would go back to c to the fourth, c squared times s squared would go back, huh? So that's fact. It would go back to be the same thing, wouldn't it? So that's called factoring. What it basically is reverse multiplying, right? If you multiplied it, it would go back. So that's called factoring. Now, why? Why do we do that? Whoops. No, just bring this over. Now, do you see what we can do?
Can we still do it?
Yeah. So are you wondering, Samuel, if I can go boom, boom like that? Absolutely. Right, because that's buying the whole package. So that's okay, huh? I'm buying the whole glued package. Hey, well, yeah, what about this guy? Well, that's the whole thing. Notice, he's times, huh? So he's separate. So it's okay. He's not glued. So you guys getting the idea with the plus or minus and how that's glued? And that's why we factor, because then you make something times and it's separate. It's okay. Y'all getting that? See how that works? So what's left then? So it's cosine squared, and that's on your sheet, right? We're there. We've arrived. That's answer A. So that was a little tricky. It looks messy just to look up at it now. So did you follow that? Is that okay? So it's kind of tricky factoring and back and forth. Look, is it okay if I just write it one time again really clean? It just got so messy. So one more time really clean. C squared minus s squared over 1 minus t squared. So the first thing we did is Elise mentioned, and it was a good idea, just make this sine squared over cosine squared. Make that tangent become sine squared over cosine squared, right? Because tangent squared is sine squared over cosine squared. So we do that. And then we looked and we said, oh, but that's fractions within fractions. That's ugly. We knew we could not just grab that and flip it up like we usually do because this one's glued to something, a minus sign. So we said, what can we do? Well, you just say that that extra denominator, which is our messing things up, multiply everybody by that. So I went c squared here, c squared here, c squared here, and c squared there. Everybody got one, right? And then I canceled. That's why I'm doing it, because it's over 1. Cross cancels. And what did we have from there? Then we had c squared is c to the fourth, s squared c squared over c squared times 1, c squared minus s squared. We got to there. Is that good? I just multiplied these two. C to the fourth. Multiplied these two. Oops. Went right there. And this. And this, right? And then we said, okay, now look at that top. You can factor. You can take out of that top. This and this both have a c squared in common. That left c squared minus s squared. And then, boom. Well, Costco will let you buy the whole package, right? I just bought the whole glued package. And this c squared, he's separate. He doesn't have plus or minus next to him. He's not glued to anything, so it's okay. He's a separate issue. Don't have to buy him also. C squared is the answer. Answer A. A little more clean that way. That's how you do 13. 13 is one of the hardest. 13, 18, and 1, I think, are the 3 hardest. Is that good on that? Other questions? So just practice these. This is the kind of thing. Just, you've got them all on YouTube. You'll write them down in your notes. And then this is what I had to do in math classes too. I'd see stuff that I would have never figured out, and then I'd write it down, and then I'd try it again later. That's just what you got to do. Literally, I remember to get out the door with my master's degree at Cal Poly, I had to do math in front of my professors. That was the oral exam. That was to get out the door with your master's in math at Cal Poly. I had to come in this small little conference room. I went up to the board with a pen, and 3 of my professors from 3 of my hardest classes in the master's program sat in the seats and fired questions at me. And I worked on the board in front of them. That was our oral exams. And I knew that day there would be no secrets, because they could ask me anything they wanted from those classes. And I knew if I kind of half knew something, they were going to question me more. They're going to say, well, tell us, Brett, why'd you do that? Well, why is that true? What's also true? They could ask whatever they wanted based on what they saw what I did. So anyway, I was very scared about that and knew that there would be no secrets that day, that they would know what I knew and they would know what I didn't know. And so anyway, long story short, I remember preparing things like this. There was a bunch of proofs. These are proofs, right? I had a bunch of proofs to learn. That's pretty much what you do in master's programs, a lot of proofs, at least in the one I was in. So I had to learn these things. And so I knew certain ones were fair game. They might ask me things like this, And so what I would do is I remember sitting in the Cal Poly library saying to myself, all right, Brett, I'd look at one of these and I think, I know that. I remember that proof. And I would think, do I really? Do I really? I'd say, all right, do it then. I'd put away my little notes, take out a blank paper, and I'd try to write the proof. I remember one time, this one particular proof I was nervous about them asking me. And I tried doing it. I got about halfway through the proof and I got stuck in the library, And I thought, shoot, I don't want to do that in front of my professors in 2 weeks or whatever. So I opened my notes back and I went, oh yeah, that's the next step. But I said to myself, you don't know it. You didn't do it. You needed your notes, right? It's important to speak truth to yourself because the truth will come out. Why lie to yourself? I mean, who are you helping? You're just hurting yourself, right? Next day in the library, went back again, tried it again, blank. I thought, I got it. Blank paper, got about 3/4 of the way through, got stuck again. Thought, shoot, what's that next step? Opened my notes up. Oh, yeah. Said to myself, you don't know it. You don't know it. 3rd day, the library, blank piece of paper, I wrote it top to bottom without looking at my notes. Then I said, you know it. And they didn't even ask me that one. I remember they never even asked me that one. They asked me some other stuff, and I still messed up and got confused on something. Anyway, they eventually let me squeak on through. But I'm saying that's how you learn math and science. I tell that story to let you know. Me too, right? I mean, sometimes you think, oh, he's a math person. He just came out of the womb, and there was just math in his head. It was just full of math. Well, yeah, I might be a little more natural at math. I was good at math from a young age. But I still had to work like a dog to eventually learn this stuff. This is what you got to do in a math class. So if you really want to learn these 18, between now and next Tuesday, you take a blank paper. You've got this right here. After you've done the homework. Not just do the homework one time and say it's good. It's not good. Well, you tell me it's good if you can do it, right? Do it like a test. Make it a test situation, which is what? Put one of these before your eyes, take a blank piece of paper or your 3x5 card, what you'll have in the test situation, and try it. Don't lie to yourself that you really know it. Try it. Top to bottom, right there, right then. Find out if you really know it. The truth will be known next Tuesday, so you might as well find the truth out in advance and help yourself. So anyway, I gave that little speech. I hope you benefit from that. That's how you learn math. It's just like that. So you got to do all that work. All right. It takes tons of time. It did for me. Number 12. Let's do, I don't know how many of these we can do. Maybe one more. Cosine minus sine over cosine plus sine minus cosine over sine. Okay. I think maybe I'll do this one and I'll stop. And the other classes coming forward, I'll go up to number 11 with them. And so they'll all be on YouTube. All 18 is the plan. Last one. How are we going to do these? How are we going to add those two fractions? How do you add fractions? Common denominator. I hope right away you're looking at that and thinking, common denominator. To add those two fractions, I got to get a common denominator. What's the common denominator going to be?
Where I can't just multiply the C on that side.
Yeah,
And
yeah.
multiply the S on that side.
Yeah, totally. You're right. That's exactly it. Yeah. So here we've got to go top and bottom by S to make that SC, and the other one top and bottom by C. That's exactly it, Samuel. Is everybody good there? Is that making sense? Let me put parentheses so we're clear it's going to distribute. So you see how it's going to make both denominators become SC, the same thing? See how both denominators will become SC? That's the deal. I want to make both denominators the same. Okay, so what's that going to do? It's going to distribute on the top. We'll get SC, SC minus S squared, boom, boom, plus CS minus C squared over SC. I can just make them one big fraction now because their denominators are the same, right? Everybody good there? Is that good? Questions I can answer so far? Does everybody see what happened there? Those are cosines and sines, but I'm just saving space and time. Fine with me if you do this on your homework too. Just write S and C. Is everybody okay with that? So I just made the two fractions the same bottoms, right? Same denominators. Put them together into one fraction. Now, what can I do on the top? Is SC and CS, are they the same thing? Yeah, order doesn't matter. They're the same thing. So I'm going to add them like terms. 1 SC and 1 SC is 2 SC. Minus S squared minus C squared over SC. We good there? So far, so good. Makes sense? Okay. Now, just cancel out the S and the C. We just have that 2. That. That good? Make sense? Is that good? Is that good? Really?
You can't cancel all of these.
Yeah, what about my Costco speech?
See, I was going to say something.
Please do. Sometimes I feel like I can do anything up here. Don't let me. I'm trying to test if my words are coming across at all. That's illegal. Costco says no, right? Right? Because this top is plus and minus together. Which means if you want to mess with the top, you buy the whole package or nothing. Right? Remember, plus and minuses package things together. So I can't do that. Right? This is glued to that is glued to that. So it means if you want to mess with that top, you buy the whole thing. Right? You do one big cancel or nothing. So yeah, don't do that. I'm just trying to help you keep thinking rightly, but it's a really important rule as you go higher in math, especially. So can't do that. Okay, well then what in the world do we do? Well, when you see this sine squared, cosine squared, what you should be thinking of S squared plus C squared is 1, right? But wait a minute, but these guys are negative. Yeah, you could factor out the negative. Here we go with factoring again. I don't know if you feel like my daughters felt a couple years ago. Dad, I hate factoring. But you got to learn to factor if you want to go forward in math. These two, you factor out a negative 1. So 2SC minus 1. So what I'm going to do, minus 1, that's a negative 1 times S squared plus C squared. Do you see that? Why? Because if that minus 1 multiplied, see how it would go back correctly? See how that's true? That's the same thing. Why? Because what minus 1 times S squared would go back to minus S squared Minus 1 times c squared would go back to minus c squared, wouldn't it? See how that's right factoring? Samuel, question. You look like you have a question.
Yeah. You say it all the word.
Yeah, so what I'm doing is I'm just saying, look, these guys both have a negative sign. So it's like they really both have a negative 1. How about that? Is that a better way to see it? They have that in common. When two terms have something the same, something in common, you can put it out in front of the parentheses and put a parenthesis and then remove it, right? So we say, hey, these guys both have a minus 1. So then you put a minus 1 parenthesis, and then you rip off the minus 1, rip off the minus 1, s squared plus c squared. It's right. How do you know it's right? Well, if you take that, anything in front of parenthesis could distribute, right? What is minus 1 times s squared? Go right back. A minus 1 times c squared. Go right back, wouldn't it? See how it's the same thing?
You're doing that so we can get the 2.
Oh, why we're doing that is because I want to say this is 1. I want to now get rid of all this and say you're just 1. I just wanted to get s squared plus c squared to appear. Because then I can go, you're just 1. I'm just trying to clean it up. Does that make sense?
Equals 1.
Yeah.
Oh, yeah.
Yeah, so I wrote it in the upper right-hand corner up here. Yeah, so my goal was to get that to appear because that's super useful. So I had to get those to both be plus. I didn't want the minus signs on them because mine says s squared, because the Pythagorean identity says s squared plus c squared. When you want to know that one cold. Otherwise, you'll have too much trouble. So you need to practice these. You need to rewrite these this weekend over and over and over. If you redo these 18 over and over and over again. Now, I know you might say, Mr. Taryn, are you kidding me? I'm working 30 hours. I'm taking an English class and a math class and a psychology class. Well, I'm sorry, but that's the truth. It took me hours of my life. That is the nature of math and science. It takes a ton of time. You have to, if you want to do well, if you're not happy with where your grades are hitting, you have to give it more time. There's just no getting around it. So what I've read over the years, when students have trouble, what I've found is they just simply are not giving math enough time. But I know life's hard. You got to work 30 hours. You got to do a million things. But nevertheless, my job is to be a doctor and say, yeah, I know, but if you don't exercise, it's going to affect your health. Whatever the reason, this is the reality. So this is the reality of math. You have to read. Like I would not imagine trying to take a test on this without having done these at least twice, and getting to where you can, on a blank piece of paper on your own, do these. So as you do these more and more, you'll recognize that theorem: s squared plus c squared is 1. So just simply time. So I see this right here. I made that appear by taking the minus 1 and say, oh, it's 1. Okay, so what? Well, now we're getting close. Bring it down here now. Now we have 2sc minus 1 over sc. Do you see that? This all minus 1 times 1 is just minus 1 there. Do you see that? All of this vanished, and it's replaced with 1, because 1 is all that. Just 1 times 1. 1. So everybody see this? S squared plus c squared, poof, it's gone. And there's just a 1 here. Minus 1 times 1 is minus 1. Right? All of this vanishes and becomes 1. Minus 1 times 1, 1. Minus 1. See what happened there? Because that's what s squared plus c squared is. That's why you want to know that one cold. It's always there to use. All right, so what? What do we do now? Well, we're so close. Now, I'm going to separate over a common denominator. What do I mean I'm going to separate over a common denominator? These are two things with the same denominator, aren't they? So I can oh, I know. Why don't I just cancel them? There we go. And 2 minus 1? 1.
Can you do that?
I don't know, can we?
No.
Good. No. I'm testing you again. Everybody good? That's illegal. Why? Costco says no. If that was times, sure, that'd be fine, right? If this was times 1, then yeah, I would totally do that. That would be my next step. But because it's a minus or a plus, Costco says this right here is a package. You go like that and buy it all, or you don't touch it. Right? All or nothing. All or nothing. So, okay, let's go back. Well, then what? If we can't do that, what do? We separate it. We go 2sc over sc minus 1 over sc. So that makes sense. That's like common denominator backwards. You tracking with me? That's a minus in the middle there. Did y'all see what I did? I just said, look, SC is the denominator. It's underneath both of them, isn't it? So just write it two separate ones like that. So just write it as two separate ones like that. And, okay, and then what? Now, can I cancel those now? Yeah, because they're just times together. There's no plus or minus up there. You're shopping at Save Mart. You're not shopping at Costco. You can buy just one, right? And the 2 is not glued to them. So you can cancel the S and the C. You with me? So what does that give us? 2 minus 1 over SC. We good so far? 2 minus 1 over SC. We're so close to being done with this problem. But we have like one more tiny step. Let me bring it over here. So, 2 minus 1 over... Now I'm going to make the SC two separate ones like that. Or you don't have to, whatever. 2 minus 1 over SC. Good to there? Everybody said?
Why don't we have one SC left? Because when we cancel them out, it just leaves the, you're saying it just leaves the 2, but don't we still have one SC left on the top? Because we're only canceling out 1?
Okay, we're not subtracting them. We're dividing them. If that was 2SC minus 1 SC, that would leave 1 SC. Yeah, if you're subtracting. Good question, good question. If you're subtracting, that would. But here I'm dividing, so the S and the C's just drop out. Just S divided by S, C divided by C. They cancel out. They're actually dividing. Yeah, good question. So it just leaves the 2. And now, what can we do with that? Well, look, this is 1 over sine. What's 1 over sine? What's 1 over sine? Cosecant. And you could put another one here. You could imagine 2 1s on the top, right? 1 over, because 1 times 1 is just 1 on the top. What's 1 over cosine? Secant. That's on our sheet. 2 minus cosecant secant. Isn't that there? Yeah. Yeah, the secant first. That's A. It's almost always A, isn't it? If in doubt, guess A. No, I'm going to mix them up on the real test. What's that?
You can do that when it's 1 over S times C. You just flip it and you just get secant.
No, I'm not flipping it. That's what it equals. Remember? What 1 over sine does equal cosecant.
I mean, like, you can, like, put them off.
Right, because that's true. What do I mean? Well, is it? We had 1 on the top here. Isn't that 1 times 1? Is it 1 times 1, 1?
Yeah.
So I can take this 1, 1 and make it 2 1s, because 2 1s multiplied is the same as 1, 1. 1 times 1 is 1. And S times C, that's what we had on the bottom. We had an S, we had a C. So I'm just saying, I rewrote that as 1 over S times 1 over C. Does that make sense? Because what is 1 over S times 1 over C? 1 times 1 would be 1. S times C is SC. So it's the same thing, and that's cosecant times secant on that. Thank you. Is that good there? And so we did it. All right, so really want to encourage you, go over these, spend time looking at the YouTube, writing these out. So good, at least especially if you want to go higher in math, if you want to go to pre-calc and calc, this is so good for your algebra development. That's what you need. The reason people make it or don't make it in pre-calc and calc and beyond is their algebra skills. It's all this stuff. It's all the when you can cancel and how do you factor and all. It's all that makes or breaks them. So this is like going to the gym algebraically. This is so good for you to spend time on these 18 problems again and again, learning those algebra rules. But we got to move on. We don't got any more time for that.